Okay, so it says in example 4, express the complex number for I using polar coordinates. So we want to change it into polar form. For a complex number, the polar form is r cosine theta plus I sine theta. So to get it in polar form, you've got to find r and you've got to find theta. Sometimes it's helpful to think about graphing this. So if I have if I have 4I, then that's going to be 0 along the real axis, and then 1, 2, 3, 4 along the imaginary axis. So this is like my imaginary, and then this is like my real axis. And so to graph that in the complex plane, it would look like that. Well, you can see then the distance from the origin to the point, right? That is going to be, oh, I'm looking at the wrong one. Okay, so you could just count that out. But, you know, if you didn't want to, you could write it out as well. So you could say r is going to equal the square root of x squared plus y squared. But r is going to equal, my x is 0 here, so I have 0 plus 4i. So you have to think of it that way. So 0 squared plus 4 squared, which if you did all that work, you'd get r equals 4. Okay. All right. But we can see that from the graph. You can't always see them from the graph, but that one we could. So we know what r is. Now, one of the reasons I drew the graph, though, was to get theta. So what is this angle right here? Well, it's going to be pi over 2. Okay, so you can see that angle from there. Now, what if you couldn't see the angle? You could form a triangle and you could find the coordinates for it. Okay, you could base it on that. But not in this example probably, but you can see it from the picture. But we'll show you that on the next example. Okay, so I get my r, which is 4, and then I'm going to have cosine pi over 2 plus, maybe I want that in parentheses, plus I sine pi over 2. Or you could use the abbreviation. All we're doing is putting this in polar form, so we're not going to do much with it. Okay, so I think there's another example now. Find the polar form of this complex number, -4 plus 4i. So again, we could draw a coordinate system and we could think about, okay, -4, 1, 2, 3, 4 on the real axis. And for the imaginary axis going 1, 2, 3, 4. And so we have that point graphed up there. But we're trying to find, remember, this distance here. Okay? And so again, r is going to equal the square root of -4 squared plus 4 squared, or square root of 16 plus 16, which is 32. And if I simplify that, I'm going to have 4 times the square root of 2. That's r. In order for me to put it in polar form, I need to find r. But what is theta going to be? Okay, so we're talking about this right here, right? Now, you can think about the triangle here that's formed. Okay, that right triangle. And you can think about a reference angle here, theta, prime for the reference angle. We know this distance, 4, and we know this, -4, and we know this distance, 4. Now, you also know the radius there is 4 times the square root of 2. Now, you can pick any of the trig functions then to work with. I would do tangent, but the book used cosine, but that's kind of your choice, I guess. So the cosine of theta is going to equal, oh, not cosine. I said I was going to use tangent, didn't I? I was all set to use tangent in my mind. Okay, so the tangent of theta is going to be the y, 4, over the x, -4, which is -1. And I can think about where the tangent's -1. That reference angle is pi over 4. But remember, I'm in the second quadrant here, right? So quad 2 here. So this theta, let me do it in a different color. This theta then is going to be 3 pi over 4, because I got to be in the second quadrant. Okay, so that's going to be my theta, and then I can write out the polar coordinates. So it's going to be z, my complex number, is going to equal r cosine theta plus I sine theta. And you certainly could use the abbreviation here. 4 times the square root of 2. Here, I'll use the abbreviation. Cis. And then my theta is 3 pi over 4. And then that would be the complex number in polar form.